This is video number 9 in the series of tutorials for constructing our Drive app, and this is also the first one, the beginning of stage 4. As usual, we have the written guide for stage 4, and the setup is to start where we left off on stage 3. Just like we did before, we're going to duplicate the scene Drive stage 3, name it stage 4 and open it. There's also a stage 4 teacher pack which we're going to unzip, copy paste to assets. It's not that big, so let's do those things. In the project, I'm going to find the scenes, Drive stage 3 and duplicate, and now it's called stage 4, of course, not forgetting to double click on it to make sure that's the one I'm editing. And also I'm going to do it while I'm recording, the teacher pack for stage 4. I'm going to copy it. Here is the project I'm working on now, which is the Drive 2025 for video, and into my assets I'm going to paste this. It takes a second for it to import. And when it does, maybe I was wrong saying that it's pretty small, because actually it has quite a lot of graphics. Here it is. The teacher's pack for stage 4. It has the 8K skyboxes, it has the water texture, and so on. Because the main goal of stage 4 is to add the look of an ocean, like, a water that we fall through, and then adding a splash detector, which will do two things: play like a splash sound when we fall through it, and between the water level and the ocean floor, change the view in what we call post-processing to kind of like an underwater look. So it feels like, like we fell into the ocean and we hit the ocean floor before it reloads the scene. So let's get started. First of all, to change the mood, we're going to change the skybox to Sky 3 mod. It's one of the things that came with the teacher's pack. Instead of the default skybox, we're going to go to Window, Rendering, Lighting, Environment. Instead of the default skybox, it's going to be the Sky 3 mod. Here it is, much more like, has more character to it. Let's leave this open in case we need to do other things to it. And it's time to add water. We're going to create an empty game object, and it's going to be called water container. Again, why container? Because it's going to have the visible part that looks like water, but also the invisible part, which is going to be the detector that detects whether we fell through it or not. So the container is going to be called water container, empty game object, water container. And looking at its parameters, the only thing that needs to be changed is Y60. Here's the idea. So let me reset it. Y60. You may remember that our track, the one we're on, is about 100 meters above ground. The ground is the ocean floor. So between 0, which is where the floor is, and 100, which is where we are, at around 60, there's going to be the water level, which means if we fall off of the track, we will fall about 40 meters before we hit the water, and another 60 meters before we hit the ground. Next. As a child of water container, we're going to create a cylinder. The whole idea of the water is it's going to be a big disc, a really big one. And its name is going to be Water Viz, but it's going to be a cylinder. So as a child, right click, 3D object, cylinder. Its name is going to be Water Viz, and let's see what we're going to do to it. Compared to its parent, it's going to be all zeros as far as position, but its scale is going to be totally different. It's going to be 1,500 meters. That's also almost a mile in width. Very thin. Why? that's why I'm calling it a disk. 0.01 and 1500 by length or depth. Also, in the screenshot, it emphasizes the fact that we either delete or disable the capsule collider. We talked about it many times. Cylinders, for some reason, come with a capsule collider. We definitely don't need one. So, WaterViz 1500. See how wide it becomes? And 0.01 by height, very thin, and 1500. So it looks like a huge floor. If I get move away, you can see that it's a big disk. So, but it's so big that it looks like we're, from our point of view, from the car, it looks like we're looking at a horizon, even though it's, basically a circle. Also, this capsule collider, I would either disable or simply remove it. The collider is going to be a totally different part. Now, let's make it look like water. So we just did step number 4. In your assets, we're going to create a folder just like we did for stage 3. We're going to do for stage 4 to keep it organized. All the assets we're creating only for stage 4. And within it, we're going to create a material called water mat. So first of all, a new folder called stage 3 developer assets, and in it, a material for the water. Which, of course, sooner or later we're going to assign to this disk, to this cylinder anyway, so I might as well do it now. And that way we can see, all the changes we're giving it. Now, what we're going to do with this water mat is assign to WaterViz, which, of course, has the water mat, the base map, which is called Volume 36.5 Base Color. So let's start. The material, base map, scroll down to the W's, water 35 base color, Vol 36, sorry. That's the one. And it already looks kind of like water. Let's make sure that I'm using the right one. Vol 36.5 base color, yes. But the normal will be a different one. This is kind of to give it a little, randomness. The normal is not based on the base map, but it's a normal that's taken from another water texture. And the normal is called Water Basics Normal. Water Basics Normal. You see how it gives it that, kind of like randomness of look. Before we're done, the tiling, because it's so huge, we're going to give it a slightly bigger tiling and all the rest of these parameters. Let's see. So we already gave it metallic map is going to be, because we want it to look like it's shiny. So first of all, let's make sure that I can see it. Okay. Metallic opaque front, yes. Receive shadows, yes. The base map we already took care of. The metallic map, now look at what it does when I increase that. See how it gives it that, very shiny kind of look. But the smoothness is not that smooth because I don't want it to reflect the light too much. Not all the way up at about 9.15. That's, of course, up to taste, and it gives it that very reflective, water kind of look. And of course, the most important thing that we're going to change is going to be the tiling to 30 by 30. And now I really get that, look of, like little waves. I think I did everything. The next thing that we're going to do, bring this back into the picture, is those waves don't move. I experimented with a lot of animations that might make the waves move. The problem is that because it's so huge, it's going to be very CPU heavy. So between not moving at all and costing too much as far as CPU, I found let's call it a compromise. It's a script that's going to basically rotate this disk, but in a way that's so slow that it's just going to look like very slow movement of the waves, because it's so big that we're in the middle of it, and it's just going to look like they're kind of like, moving around us, but in a very subtle way. To do that, we're going to create a script called self-rotate, and we're going to put that script in my scripts, and it's going to have very few lines. So let's see if I already have that script. Self-rotate. It's in my scripts. I created that. I have already that. You're going to create the script self-rotate. You're going to open it. At this point, you probably want to pause this video and type what you see in the written guide. But once you do, assuming you are coming back, it's going to be actually fewer lines than... here it is, it opens. Fewer lines than the default code, because it's really, really simple. Let's wait for it to open. So again, it's called self-rotate with a capital S and a capital R, and it doesn't have a start. It has only the using Unity engine, and whatever object we assign it to, update, of course, means it'll keep looping every frame 72 times a second. So every frame, or 72 times a second, a 72nd of a second, it's going to transform whatever object it's attached to, rotate, vector 3 up. We discussed this before. When I roll over, it even tells you that it's a shorthand for vector 3, 0, 1, 0, which means no rotation on the X, rotation only on the Y-axis and clockwise, and no rotation on the Z. So it's going to rotate only Y, basically rotate like a disk, like a revolving door. How much will it rotate? 0.2 degree every frame. So it's going to take it a long time. If it's 0.2 degrees every frame, it's going to take it like a whole minute or even more to complete a complete rotation. So it's going to move very, very slowly. Assuming you type this correctly and you don't see any, errors in the console, let me clear that. The next step would be to WaterViz, add a script. So to add that script to WaterViz, we could have added it, by adding component or writing it independently and assigning it to it, as long as it's there. So now the WaterViz has a script called self-rotate. It doesn't have any fields that we need to fill up. And when I play, I want you to see what will happen. See how it looks like very, very, very subtle movement. When I look at the vectors, you can see that it's rotating extremely slowly. I was going to say it's going to take it a minute, but it's probably going to take it a lot more. I found that this speed is just fast enough to create that impression that it's like very nice still water, but it's still moving. See how it's like? Now, if you think that that's too slow, you could simply change the number from 0.2. Look, if I changed it to 10 times faster to 2. By the way, F is because it's a float. I want to be able to use, floating point numbers. If it was 2, it would just, to my taste, look a little too fast. This is 2 degrees every frame. And it's also kind of reveals the fact that it's rotating, that it's, it doesn't look natural. So I think that a very subtle movement like I had, the 0.2, achieves exactly what I want without costing too much CPU. So now that we got the water to look right, we're also going to go back to the directional light, to the sun, and change its parameters a little bit. Again, I want a little more mood. So the directional light, which is the sun, let's see what we're doing to it. It's transformed. Remember, the X and Y of the sun is basically the time of day and the geographical area that you're in. So especially the X, I'm going to change to 120, and it definitely changes the whole way the sun shines. And instead of -30 on the Y, it's going to be positive 25. And again, it's the whole reflection of the light changes with that. It's directional, it's real time. Instead of filter and temperature, I'm just going to use a pure color. I'm going to make it a little bit yellow, just like, a touch, to warm it up, like eggshell yellow. I'm doing this by eye. Intensity, instead of 2, will be just 1. It doesn't need to, be that strong. Default, everything soft shadows with, strength all the way up. And it's using the strength from the render pipeline. Everything else is the same. The universal additional light data we don't need. We just don't want to task our CPU with that. I think this will be a good time to stop this part of the tutorial, and I'll see you in part 10, which will also be the second one in stage 4.